let's get started. You all are on time and it's excited to have you here. So we're going to get started with our presentation on project-based learning and 3D printing with Damon Crumley, the curriculum director at Learning Blade, who I like to also think of as a 3D printing guru. And myself, I'm Josh Snyderman and VP at Learning Blade. We are celebrating this event as part of the South Carolina STEM Month activities. And so we're just really excited for our partnership with the South Carolina Coalition for Math and Science and for SC Tech and for all of our partners in South Carolina to get, educators doing awesome STEM in South Carolina, but we're also joined by teachers from South Africa and Florida and Missouri. So thank you everyone for joining. And let's just dive in. Let's dive into Learning Blade's PBL and 3D printing lessons. What I'd like to do is just start with a little bit of simple background. What is PBL, project-based learning? This is a really simplified definition on the screen. And what it says here is that it's a teaching method where students learn by actively engaging in real world and personally meaningful projects. I like to think of it as learning by doing. And it does have this cycle, this iterative design, this concept of coming back and synthesizing and reflecting on the work that students do. I think that's a critical part of PBL. I actually, in my fellowship, I remember hearing it's not engineering if there isn't iterative design, if there isn't a second chance to improve that design. And I think there's a lot of different ways to do project-based learning, and we're going to share some of the Learning Blade resources to do that with you today. We also want to talk about the benefits of 3D printing, and that's why it's really exciting to have Damon, who's a master 3D printer, shared some of the creations in Learning Blade. But we did a webinar last month with a 3D printing teacher. He was talking about how it creates such excitement for the students because it's additive manufacturing and it's rapid prototyping, which we'll talk about later. It complements the curriculum in so many ways, particularly obviously in the ability to really do three-dimensional thinking. And then it's new possibilities. I'm sure you guys have seen the videos of 3D printed cars, 3D printed houses, 3D printed shoes, 3D printed organs. The possibilities for where 3D printing is going is just like computer bandwidth, where we talk about Moore's curve, where the exponential growth in computing power. I believe the growth of 3D printing is similarly exponential, and we're at the very start of it. So you guys are like the trendsetters in education for being here. And then absolutely, Damon will talk about today how it promotes problem solving. So actually on this first page, we had pictures of our 3D printing hand. That's one of our lessons. On this one, you can see these gentlemen here are with our 3D printing earthquake shaker table that they built a structure on. We have a prosthetics lesson where students did that on this other picture here. And exciting, we actually give away 3D printers. I know some of the teachers on this webinar have received them. So how do you win a 3D printer? In South Carolina, as part of South Carolina STEM Month, the school that completes the most lessons by April 11th will win a 3D printer. In addition, any school in South Carolina, in fact, any school in the Learning Blade universe, can win a 3D printer by completing 3,000 lessons this school year. And that's made possible through an incredible partnership with Flashforge USA. And Damon, maybe when you do start talking, you can talk a little bit about how much you like that printer, because we in our office use it 24 hours a day, almost 7 days a week, and it is the bomb. It's really great. So yeah, we hope some of you are on track and on target to win a 3D printer. And if you're curious where your school is on that path, you can email me. My email is joshua@learningblade.com, and I'm putting that in the chat box. So let me ask a chat box question. Let's get some chat box going on. Who's done 3D printing lessons? You can just say yes or no. We'll just see the yes or the no's come in. So Amy has, Jennifer's no, we got Stacy's no. We got some yeses from Tracy and Barbara, great, and some no's. So we've got a mixture of experience and not yet. I like that. Blankenship, that's great. So, yeah, so there's a mixture happening here. So that will be great. And we will take your questions in the chat box as well. So feel free to share some of those as we get going. Real quick about Learning Blade. So when we talk about the 3D printing lessons in Learning Blade, that actually is part of a larger picture. So Learning Blade missions focus on career awareness in computer science and STEM. They're interdisciplinary with math and science, English and social studies lessons, and even video lessons. And really what our 3D printing lessons do in our project-based lessons is a complement to the whole bigger picture, which is STEM career awareness and getting students really to get inspired about their future. We like to say at Learning Blade, you can't be what you can't see, and we really want students to see the careers and the possibilities. So part of what we're really focusing on today are two elements, the 3D printing and the mission challenges, design thinking lessons that, that complement the Learning Blade online missions. And as you can see here, there's 12 missions in Learning Blade. Each one has 10 hours of curriculum, but also each one has a 3D printing lesson. So the lessons that Damon's about to show you are part of the theme of the career awareness in that field, in that industry, in that career path. In addition to the 3D printing lessons, we do have our mission challenges. So I'm about to hand it over to Damon, but before I do, I want you to know where in Learning Blade can you find the things you're about to see. You would log into your Learning Blade account as a teacher, and you would click on the resources button. When you do that, that's going to take you over to the resources page where there's all these orange expandable folders. If you click on the lesson plans for 3D printers, that arrow's in the wrong spot, on the 3D printer lessons, that will take you to the 3D printer lessons. If you click on the mission challenges, that will expand up and you can see all the mission challenges, and we've got design thinking and paper craft and parent activities. So there's a lot here for you, but it's definitely on the teacher resources page in the 3D printing maker and 3D Maker Quest folder. Well, Damon, let me stop talking. Let me pass it off to Damon, and Damon's going to sort of show you how these lessons complement the bigger mission and really all about the 3D printing activities in Learning Blade. So the lessons have downloadable 3D printable designs. You can modify them online, and they come with instructions for all the activities. So this is a screenshot of our first activity. We're going to talk about our concept car. Let me stop sharing and allow Damon to show his screen. So go ahead, Damon.
All right. Thank you, Josh. So yes, what we're going to deal with first is one of our experiments in the car manufacturing mission in Learning Blade. Now, the idea of this mission is the student is imagining that they are in a contest to design a brand new type of car. So in the mission, they'll learn about all these different STEM careers and technologies that go into that real world task where, you know, new cars are being developed every day. So with the experiment that you're going to see here, I'm going to go over to my experiment table, and you can see that basically to get set up is very easy. You're going to need a board and some sort of elevation. I've just got a stack of copy paper here, and I'll show you in a minute in more detail how to use the 3D printer to do this one. But this is an experiment that could actually be done with just a model car. So if you're one of the teachers that maybe doesn't have a 3D printer yet, you could still run the same experiment and still teach these same concepts with a car. It's just that with the 3D printed car, you're going to get that added dimension where the students can actually go through and make changes to the car. So here's how the experiment basically works. What you'll need is a ramp. You're going to need a scale so that you can measure the mass. And then we've got a printed out sheet here so that we're going to record our results. And so the idea here is we're going to roll the ramp, the car down the ramp. And I'll start with this one first. So I've got a little piece of tape here where I'm starting, and I've got a little piece of tape here where it ends. I've got my smartphone out for timing. Let's see, I'll turn on my scale, let that zero out, and then I can measure the mass. And so that's about 39 grams. So I would make that recording on my worksheet there. So I know this car is 39 grams. And now we're going to run a test where I put it up at the start. We'll see if I can do this all together. And I let go and I start it and I stop when it gets to this one here. That took about 1.86 seconds. Now, I would actually run this several times and make recordings here and then do an average. That's something that whenever you're doing measurements, you want to try to work out little imperfections in your measuring methodology. And so we have that done as well, where that teaches them good practices. Then the next part would be you would take tape, you would add some weight, and here I've just got pennies, but you could also use washers. And then you'll do your mass of your car at this new mass with all the weight on it. And then I'll run the experiment again. And again, I will take my measurements. I've got that there. I'll run that 3 times. And then I make that notation on my graph. And so you can see that the heavier that the car is, it's actually faster. So I can plot these points between where it is when it doesn't have any weight and where it is when it has a lot of weight. And I can draw a line between that. And now what I can do is I can take away some of the weight and go somewhere in the middle. So it has a little bit of weight, but not what that maximum was. Oh, and then I measure my mass. And so somewhere that mass is going to fall on my curve. And what that's going to do is allow me to predict what's the speed going to be. So you would have your students do that, have them make their prediction based on the math. So here, my mass probably falls about right there at 44. So that means that it's going to be about 2.6. We'll see if I can measure that. I'll clear it out. And let's see. Okay, about 1.55. So if I ran that several times, I would go through that and hopefully get something more accurate. But what this does is it talks about testing, it talks about car design and all of that. Now, if you have a 3D printer, you can go one step further, because with a 3D printed car, in the exercise, you'll be able to download the files, you can print out the car, and you can print out the wheels. And the nice thing about that is you can print out different size wheels. We've given you some different size wheels, but we've also given you the 3D model files so that you can go into CAD software. And I'm actually going to pull up something here. So this is Tinkercad.com. It's free, and it's basically very easy to use CAD software where you can import the models. Like this one is a wheel with no tire on it. So that hole on the center is exactly the right size to snap onto the car. And actually, let's go back and look at a close-up of that. These wheels pop on and pop off, and I'll make that focus there. So you can see how that works. I could print out new wheels and snap those on, and then I could run this experiment and do my measurements and see what effect different size wheels have on this experiment. Now let's go back over to Tinkercad. Since we're giving you all the files, you can make changes, like you can make larger wheels, you can change the design of the car. Another suggestion that we've had recently is if you have an action cam like a GoPro, you could download a 3D model file for a case that it will snap into, and then you could actually go and model this. And let's see, I'll actually rotate that a little bit so it'll sit on there, and then I can drag that over, and I could, let's see, lift it up just a little bit. About right there. And so now I could have this model. So instead of just putting weight on the car, I could actually have an action cam on there so that when I roll it down the ramp, I could actually record videos of it from a first-person view. So that adds another dimension to it. So with the 3D project, you're getting that advantage of not just doing the measurements and the recording, but you're giving students that challenge of going into CAD software, doing 3D modeling, making changes. So one of the things we talked about is rapid prototyping. Rapid prototyping with 3D printer is so wonderful, because if somebody makes a change, you can immediately print it out, and then that same day you can run it down the ramp and you can see what the effects are of that change. And so that's a really important skill. It's a STEM technology that lots of jobs are using nowadays. And so that lets you reintroduce those careers to your students, because you could have contests. You could say, okay, redesign this car, make it go faster, or let it hold more weight, or let it hold a camera like we just saw in that one example.
So if I may, Damon,
right there.
If I may just add, so this is all of our 3D printing activities are about collecting data. And so I think that's what makes them ultimately unique and meaningful for teachers, because as Damon just demonstrated, if you don't have a 3D printer, you can do it. All of our lessons come with the non 3D printed version. But what Damon's showing you is how students can use a program called Tinkercad. And then you can have students adjusting variables, manipulating control and variable of a car, and really doing authentic project-based learning, authentic testing, experimenting, gathering data, interpreting data, and then redesigning through that engineering design process. And so the next lessons will show you will have that same element, but I think that's one of the exciting pieces of the Learning Blade lesson. And just to reiterate, this is about car manufacturing. This 3D printing lesson goes in line with students learning about safety administrators, test tracks, automation mechatronics, welders. It's really teaching them about the careers in the automotive manufacturing industry. And then they're having sort of a real life sort of example. Well, guess what? They test and gather data on their cars too. That's what we're going to have you do in this experiment. And so I'm going to share my screen again, Damon, if you don't mind, real quick. And yep, thank you. And sharing my screen. And I'm going to, so here's that lesson for manufacturing a concept car. You can see in Learning Blade some of the careers that students can learn about. There's a social studies lesson about groundbreaking designs, an English lesson about dreaming up designs using English standards. There's a science lessons talking about how an engine works and power and torque, and a math lesson about aerodynamics, and then a video lesson. And that's all just for automotive designer. So for each career in the online lessons, there's about an hour of curriculum. There's another hour for mechanical drafter, another hour for paint technology. By the way, do you know how they get that perfect paint on a coat of the perfect coat on cars? We've got a science lesson here. It's about a 10 to 15 minute science lesson. They use static electricity. I didn't know that. So anyways, Damon, let me ask you a little, can we talk a little bit more about rapid prototyping in terms of, how do 3D printers model the real world in that sense?
Well, they're very useful because in the old days, before 3D printers, whenever an engineer or scientist wanted to test a new design, what they had to do was build a model of it. And typically building a model would be out of wood or plastic or clay or some material that it would take a long time to sculpt or machine. And you would have to go very slow to make sure it was exact. And if you mess it up, you might have to start all over again. Rapid prototyping especially comes into play with 3D printing because when I model it digitally, I send that information to the printer and I know for the most part that when that part comes out, it's going to be pretty much exactly what I want. And if I need two of those, I hit the button again and it prints out another one. So what that does is it means that instead of sending my designs off to an artist or a craftsman who has to then machine the product exactly like I want, and I hope they get it right, with the machine doing it in 3D printing, it's a lot faster turnaround time so that I can make changes to my design, print them out, and start testing them that same day. Whereas it might take days or a week or more in the old days where you had to have a craftsman actually machine these out of metal or wood or plastic or something like that.
That's a great answer. And in fact, that's what much of industry and business is now going to, is this rapid prototyping model. So it's not only faster, this is 21st century skills. Mm-hmm. Just a quick fun story. We work, some of you may know a gentleman we work with, but his son came to Learning Blade and saw the 3D printing and got excited about it when he was in about 8th grade. He's now a junior in high school and has his own 3D printing company. He bought a high expense. He went to the bank, got a loan as a 17-year-old, and now is manufacturing parts in his garage. And it's all because he saw what 3D printing possibilities can do. And so that's Jared Bigham, but that's pretty exciting, the opportunities and the possibilities of 3D printing. Do any of you on the chat box that use 3D printing, I mean, do you have a story of like a aha, wow, when students realize what a 3D printer is capable of doing? We'd love to see it in the chat box and maybe share it. I also see a message in the chat box from the USC professor. We'd love to give you an account. Absolutely. My email is joshua@learningblade, and we can talk about that offline. So Damon, we're going to go into the next mission and really share with people, and you got time, so take your time.
Okay.
We've got the glider airplane. This is my personal favorite because it's just so cool. And this goes along with Learning Blade's aerospace air manufacturing concept, advanced manufacturing in the aerospace industry. And so let me stop sharing my screen and let Damon do his thing. Damon, go ahead and tell us about this activity.
Okay, so this one is in the Learning Blade lightweight aircraft mission. And the story of this mission is that you have a friend who works in a relief organization that has to send people and relief materials to far-flung places of the world that they may not be able to have good roads or other transportation methods to, or they may need to get something there quickly. And so what she needs is a new type of lightweight aircraft to be developed that will carry the cargo and the personnel that they need to remote areas of the world. And so you are helping her put together a team of experts and you're going to meet with a company that specializes in aircraft design and manufacture. And so in the mission, you learn about all these skills and technologies that go into aircraft design and construction. So with our experiment here today, again, I'll transition over to our table here. The non-printed 3D, non-3D printed experiment is a very typical one that you'll see done in a lot of science classrooms. Whoops, bang on my camera there. It's basically using a piece of paper to create a paper airplane. And you would, have everybody do their designs, and you would throw these, and you would track them on the graph and see which designs were best. Now, an added part of this experiment is you can start adding weight and measure the different performances of the airplane based on different weights. So here I've got some paper clips, and if I attach those to my thing there, okay, oh, that one's on there, and then there. So I've got these, and again, like we did with the model car, I've got my weight on there now. I could take my measurement here. Let's see, that zeroes out.
Y'all want to buy any candy? Is she selling drinks too, Max?
And so that's about 6 grams. Yeah, that's about 6 grams. So I would make that notation on my worksheet, and I could add more weight, and then I could gauge the performance of that paper airplane. So this is real life testing that you would do on a design. Here you're just using paper and paper clips. So that's a very easy way to do it if you didn't have a 3D printer. But if you have a 3D printer, it gets even cooler because there is a lightweight glider model that we've created that you print this out, and it's very thin. The wings are very flexible, which is really nice. You've got a little cockpit piece there that I printed out in green, and the tail piece fits down into a little slot in the tail. And so you would print this out, pop it out of the printer, assemble it. It's very easy, and then you could throw that. Now, we also have a launcher, and the way these are designed, there's a little hook on the bottom, you can see right there. And so the rubber band, let's see if I can do this without losing it. I don't want to launch it across the office. But basically, we have a simple launcher there. Now, what you can do, since this is a 3D printed exercise, let me pull up Tinkercad here again. We give you all the parts of the aircraft. So if you wanted to make the wings bigger, you could go take them in there, and I could start making the wings bigger. So now I've got a much larger wing. I would want to duplicate it on that other side. So I'll copy, I'll paste, and then I'll use the reflect tool to reflect it on that side. And then I could put that onto there, and I could make a change that way. Or I could add multiple wings if I wanted to. I could do that, and I could change it that way. Don't know how that's going to fly, but again, that's one of the cool things. We can do rapid prototyping. Now, I could also design my own launcher if I wanted to. I could make it more like a slingshot. I could make it use multiple rubber bands. Basically, anything I wanted to do as a teacher, I could make that assignment and tell my students, okay, here's what the basic plane does. Can you improve on this so that you can get it to fly further? And again, you would be graphing it in the same way that you would have done with the paper airplane, but here you're doing it with 3D printing. So you're doing that rapid prototyping where you're creating all these different types of planes, and everybody is getting to fly them and test them out. And the really nice thing about this experiment is it's so quick to print. Sometimes with 3D printing, depending on how big the model is and how detailed it is, it can take hours. You know, there are some printings where it'll take like 12 hours maybe. Actually, none of ours really take that long, but there are some, believe me, you will get some if you do 3D printing long enough. You'll get some big prints that will take, you'll have to set them and then come back and get them the next day. But this right here, oh, this prints out, I think, in under 15 minutes. This is like about a 7 or 8 minute print job. So very quick and easy to do. So if you've got students who've made changes to that, they can quickly, I mean, this is rapid prototyping right here, where you make a change, print it out, and then in 20 minutes, I'm testing my new change, go back, make another iteration, another change, test that one. So this is something that can be done very quickly. This is a really good project for that.
Damon, can you show us how the wings on that are flexible? I always am amazed that it's such a thin layer of 3D print that the wings are bendable, really.
Yeah, you can see how thin that is. That's really only about, I think, 2 or 3 layers of the plastic when it gets 3D printed, and it's very flexible. So it's a pretty tough plastic. But if you noticed when you were flying it that it maybe curved one direction or the other, you could bend the wings up a little bit, crease them a little bit, and try to even some of that out. So it's a very forgiving material, and yeah, and this is a great experiment, especially for first time out. You're probably going to have a lot of success with this experiment.
And for the science teachers out there, as Damon was talking, I'm sure you were thinking, so simple to do independent and dependent controls. You know, it's an easy way to have students only manipulate one feature of their plane and then test it. And then you can see how your variables affected it. So we've got some questions coming in. First of all, we had a comment from Tracy Elmore that the Tinkercad is such an easy and wonderful program to use. And I think I would attest to that. Damon, what are your thoughts on how easy Tinkercad is to learn?
Oh, I love it. I mean, it's free, so that's one of its best features is you don't have to pay anything. But it is surprising how much you can do with it. I mean, it seems very basic when you first get in. I'm actually going to jump in and show you how quick and easy it is to do something kind of complex. So the idea of Tinkercad is you're working with basic shapes. So you put one in here and I can see what its dimensions are. Now I can make changes to that with a slider, or I can directly enter those in. So I can make a change that way. What's really nice about Tinkercad is how you can group shapes together. So if I select both of them and then I hit this group button up here, now it merges those into a single shape. So now you can see I've got this complex shape. Another really cool feature of Tinkercad is if I want to, I can turn this into a hole. So you can see here it shows red, but if I click that, now it's a negative version of that space. And so what that means is if I put that within another shape, something like that, and now I select both of them, let's see, select both of them, and now if I group that, now I have a hole that is that complex shape that I started with. Exactly. And so everything we do in Tinkercad, all these experiments in Learning Blade were created in Tinkercad. So if they look super complex, that's because you can do some really neat stuff in Tinkercad.
So a couple more comments. One came in from Brandy, and this is a pretty exciting comment. Is she talking about how her students are 3D printing parts that they used with their microbit circuit board. So this is really, you know, when you think about it, this is mixing the 3D printing with the coding and doing some fun stuff. And Amy Polanowski, who's on the call, she actually had her students design a code. It's one of the 3D printing lessons in Learning Blade called Code to CAD, where students designed a shape using code, and then the code was printed as a 3D printed object. So you could see your code turn into a 3-dimensional design. And then Tracy Elmore had another comment, and this is actually really cool, that Tinkercad does have a whole thing on circuits as well. So let's move on to our next activity. I'm going to share my screen I think one more time, maybe not the last time, but one more time here. And we're going to talk about our wind turbine lessons. So this is actually, I said the airplane was my favorite, but being that I was a former fellow at Department of Energy, we got to talk to kids about these renewable energy resources that are coming online. Even yesterday, the government made a comment about more wind, more offshore wind. And so Damon's going to walk us through our wind turbine lesson. Right before he does, I want to make a point here. On the right side of my screen, you're seeing the mission challenge, which is the hands-on, recyclable material. We've designed a lot of our lessons that are the non-3D printing side of the same idea to be recyclable so that they're low cost, and we call them kitchen sink. You just ask kids to bring those materials in. So, but I also want to point out that this is just one of the lesson plans on the Learning Blade resource for mission challenges. There's also more lesson plans there for group discussions and open-ended writing prompts. And so there's more. What we're showing you today are just two of the many elements inside a Learning Blade. But Damon, why don't you show them the wind lesson and really show them again, just like in the other ones, how teachers can get students to design their own imagination into the project and then test that and gather data on that. That's the critical part here, teachers. We're not just designing for fun. We want to test them. And Damon's going to show you how we do that with our wind turbine activity. So Damon, I'm going to unspotlight myself and take it away.
Okay. So yes, in our wind turbine exercise comes from a mission, the energy conservation mission in Learning Blade, and the story in that mission is that your city is starting to have problems with its power capacity, and its older coal-fired generators aren't meeting capacity. It needs to expand energy capacity, but it wants to do so in an environmentally responsible, energy-conscious way. And so you're going to learn about, in this mission, energy conservation, environmental protection, all these different ways of generating power and distributing it to people who need it. And one of the growing sources of renewable energy is wind energy. And so with this experiment, I'll go over to our experiment table here. This is how we do the basic experiment using common materials that you could find around the home or even in the classroom. Basically, you take a bunch of straws and cut them and tape them together, some paper for some wind turbine blades right there. We've got a 2-liter bottle that is my turbine tower, and then I've got a 1-liter bottle that's going across that is the housing for the wind turbine. And I've poked a hole in the back with a pair of scissors so that the turbine axle goes through there. And then on the front, you could either drill a hole in the plastic cap, or in my case here, I've actually just got a piece of paper with a hole in it that's taped on the front. So very easy, and I've got some weight in my 2-liter bottle so it doesn't fall over. And the way this works is, once you've got it all set up, you can turn on a fan, and let me take off my headphones real quick so I can reach the fan. And so when you turn the fan on, it will now start spinning. And you can see that there is but it got jerked up real quick. There was a thread with some weight on it, some paper clips. So what you can do is, to measure the efficiency of your blade design, you can actually time how long it takes to reel those weights in. Another thing you could do is you could tape a piece of cardboard or a piece of construction paper as basically a needle that would spin around, and you can calculate the revolutions per minute of your wind turbine. Now, again, you can also, these blades are just taped on there and they're very simply shaped, but you could get creative with them. You could change the angle at which they're taped on and see which ones are more efficient. And you know which one's more efficient by which one spins faster when you place it in front of the fan, like we've done here. So that's how the basic experiment works, using just common materials that you're going to be able to find around pretty much any home or even any classroom. So I'm going to move that one out of the way. Now, let's get really fancy here with a 3D printer. So I'm going to slide this one over. And you can see what I've got here is a very nice looking wind turbine made out of 3D printed materials here. We've got a little disc on the top that we've drawn a line on. We can calculate how fast it's going when we see that line getting past this needle, so that'll start spinning. I've got different blade designs that snap in here, and this is where you get to be very creative with 3D printing, because, let me switch over real quick. We give you the files in Tinkercad, or you can go into Tinkercad. We give you the files of what the base of the blade, turbine blade is like. And so it's this little part here that snaps in. So you can start making your own design. Now here, I've got a little triangular solid piece, and I'll just drag it over to there, stick it somewhere in there. And then I'll take another, this is an oval solid that I've turned into a hole. And I'll zoom in so you can see what this is doing. If I turn it over that way, you can see how it's going to subtract out a profile of that triangular piece. So I'm going to select both of those, and I'm going to group those, and that will combine them. So now I have sliced away that entire piece. And so then I take that and I select the base, and then I hit group, and now it will combine them together. I can change the color if I want to, but again, the color doesn't really matter because it's whatever plastic filament I have in the printer is what it's going to determine the actual color. But this way I can see it a little bit better. So what I could do now is I could take that, I could copy it, make one there, make another copy. I could print out all three of those. And then once I've done that, I'll have blades that are very similar to this. In fact, the process I just did is very similar to how I created these blades. So let's see how these work. So now if I turn this in front of the fan, you can see it spinning. And you can see I've got the line there. So I could take out my smartphone and I could do it over a minute or 20 seconds, and I could count how many revolutions that's doing. Now, because it's 3D printed and because we give you the files, you could have a contest in your class where you could say, okay, let's see who can make the most efficient wind turbine blade design. Yep. So what I can do now is, let me take this away from the fan. I've got some over here that are some weird designs. Look at that. That is pretty crazy. So what we'll do is we're going to pull that out and start snapping these in. Got 3 of these. That one there. 3 of these. There. Okay. All right. So those are in place. I'll put this one back in front of the fan. We'll see what happens. All right, I don't know if you can tell in the video, but this line is blurry because it is going much faster, because the way these blades are shaped, they're cup shaped and they're catching a ton of wind. This fan is putting out, relative to the size, a lot of wind. And these blades, thin as they are, did not capture as much wind. These blades are very large, and so they're capturing a lot of that wind. Now, there would be a point if I made them so big, they would be so heavy that I would get a diminishing return. But again, I could graph all of this out. I could graph blade design 1 and see how fast it turned, blade design 2, how fast it turned. I could also move these back, because if I move this far enough back, then the weight, oh, I've gone out of focus, sorry. If I move this really far back, then the air has died down, the wind has died down to a point to where the weight of these blades starts slowing it down. So if the wind is below a certain speed, it's actually better to use a blade design that's thinner, that has less weight to it. So we'll put this back over there. And again, I think, yeah, I showed you over in Tinkercad, it's very easy to make changes to our blade designs. But yeah, this is a great project for more advanced students who really can get into Tinkercad and make some really cool designs. But this is a great one because it illustrates the wind turbine technology, but also gives them firsthand changes to rapid prototyping and being able to make changes to the shapes that way.
That was great, Damon. And I would say to everyone, again, authentic data collection, right? I mean, you're really getting students to think in the profession of renewable energy or wind turbine design or something, and you're showing them how data collected helps make more informed decisions. You know, many of you have done the popsicle stick bridges as an experiment. Who's going to be the first? And it looks like someone already put in the chat box, as Susan did, to have their students do, instead of a popsicle stick bridge engineering challenge, yours is the wind turbine blade engineering challenge. So there's a lot of different ways that Damon's showing you now. What we've shown you today is 3 of our 3D printing lessons. You're gonna have to go to the resources page to see all the other ones. There's 12 of them. Oh, Damon's got one there.
I got this one here. You mentioned Popsicle Bridges. Yes.
Yeah.
We actually have, let me go back over to the experiment table here. So this is one where basically by printing out a whole bunch of pins and spans, and I've got a bag of them right here, you can snap these together like this and you can make bridges. And if you made a long one, you could put bricks on it and you know, elevate it, and you could actually measure the deflection of it. Well, here you can also print out extra pieces, like if you designed a crank and just used a string, let me hold this down, you can actually now make this into a drawbridge. So
Wow.
Extra little cool things you can do with it, all starting with very basic shapes like that.
I haven't seen the drawbridge before, so that made me smile. That's pretty cool.
Yeah, I did it since COVID, so you haven't seen it.
Yeah. Let me share my screen with everyone one more time as we sort of wrap things up and take questions and have a conversation. I do want to point out, can you guys see my screen, Damon? I'm thinking yes. Yeah, great. Damon made a bunch of videos, or Learning Blade's got a bunch of videos now for about these lessons, and you can find them on our YouTube channel, where we also have some great teacher interviews with some of the teachers on the call today. Hello, teachers. But we've got, so there are lessons there with the video lessons with Damon walking through how these lessons work. And again, we are working with Flashforge. Damon, can you talk about the Flashforge printer real quick and your experience with that printer?
Yes, actually. Let me go grab it.
Yeah, you go grab it, and I'll go on to my next slide, which is, are there any questions that we have? Any questions, or, you know, we can definitely unmute. This is the unmute section where we want to, you know, have a conversation. So, you know, the one thing I'll say about some of the lessons Damon was just showing you is that some teachers, the way, if you only have one 3D printer, the way that teachers have used Learning Blade is they use the online lessons, the academic work, the rigorous reading and math and science, and they say the students that have the highest scores, that's the order in which you get to print. So they really try their best to do their best so they can be the first to print. But are there any questions? Well, Damon, let's go to the Flashforge printer, and then we'll take your questions. Go ahead, Damon, tell us about that printer you got there.
Okay, yes, I love this printer. We've worked with several models over the last 6 or so years, and of different various printers, but let me tell you, this Adventure 3 is a really good printer, especially for the money. It gives you lots of features. It's got a heated bed. It's got a removable build plate, which is really nice. It's flexible, so it's easy to get the parts off. There's a webcam in there so that you can actually view what's going on. That snaps in place. If I push it right, there we go. It's got an LED so that the light comes on. It's just a great printer. It can do various different types of plastics. Most of the plastic that I use is PLA just because it's so affordable, but you can do other versions of plastic filament in there. And it's just a great printer.
And it's quiet.
Yes,
it's because of the case,
so it's quiet.
It's really a lot more quiet than other printers. And that's the one that I'll go back to our, I'm gonna share my screen just so everyone has this.
Mhm.
You know, if you have questions after today, you can come to info@Learning Blade or my email, Joshua@Learning Blade. We're happy to answer that. But again, you know, we started here with that you can win a 3D printer. There's still plenty of time. Some schools do it in a couple weeks. Some take many months, but through your activity in Learning Blade, you know, you definitely can win your school a Flashforge 3D printer. So we hope to provide that to anyone. Is there anyone on the call that won a Flashforge 3D printer that's using it and wants to tell us how they're using it? Yeah, go ahead, Brandy. Ask to unmute.
Okay, there you go. we use it for so many things. So we started off absolutely just using it with our Learning Blade lessons. One of the things that the students liked the most was the coding with the mountains and the little rover. And that turned into such a much bigger project. They would lay out, I had a grid, and they would code which way the rover would have to move and get around. And that started off simply. But then as they started working more and getting into Tinkercad and starting to realize that we don't just have to use these templates, we can actually start, well, what if we change this? Just like modifying the blades and things like that on the airplane. And they became a little bit competitive, and that was pretty cool. And then that moved into, so now we're working with our little spheros, which is little robots, the round robots. Well, what if we could build a chassis for these to make it like a bigger type of vehicle? Well, we would need something to, say, measuring the size of the ball. What could they put around it that they could connect the Legos, like other things that you might have, pipe cleaners, things like that. So that's how we're using it. It just sort of, it's really sparked their interest. And what else can we do?
And Brandy, you and Dame and Brandy, you need to be precise with the measurements that students are making. You're really teaching them not just, willy-nilly measurements, but like precision matters, right?
Right. Oh, absolutely. And then I hate waste. So and when something is going to the printer, it has to be correct. So we're going to take a look at it, and we're going to, we use the Flashforge slicing as well. So is it going to need supports? What is this going to look like when it prints? How is this going to print? What about this space underneath it? How is the 3D printer going to accommodate that? We can send those prints to the merge cube. We can take a look at what they're going to look like with the merge cube before it goes through and uses the filament. And like you said, yeah, absolutely, the competition. Get yours done first. You have your plan, then you're the first to print. So it's been great, and it really does make everything seem possible.
Thank you, Brandy. That's awesome. Anyone else out there? Are there any questions about 3D printing? We got Damon, who's an expert. We got others on the thing here. So let's see. Did you see this? Can Tinkercad be loaded on Clever or Schoology? That's a great question. It is a website, so you can just go to Tinkercad. In terms of loading it into Clever or Schoology, that would be a question for your district's IT team. I don't know the answer. Does anyone out there know if they access Tinkercad through Clever or Schoology? You can answer, and then that answer would let us know. Tracy's got her hand raised. Go ahead, Tracy. Go ahead and unmute yourself.
Hey, I don't know if it can go into Clever or not, but you can put it on like the little icons underneath the most icons that you use. But Tinkercad also, you can do a classroom in there. So you can set your classroom up, and then their designs would be within that classrooms, which is cool because then you can see all their work.
Yep.
We use our 3D printing in so many ways at our school. I've used it when we were during the pandemic. They made mask extenders for our medical personnel and assisted livings and nursing homes to help with wearing the mask all day long. And my students, since that precision and that measurement is so important, one thing that I've learned, I use it with my 7th graders. They don't know how to use a ruler, and they don't know how to measure in millimeters. And Tinkercad does millimeters for most part. But I make them create a toy box. So I give them a measurement of like 80 millimeters long, 40 millimeters tall, and they have to put a shape in the top of it, and they have to create the shape that will go inside, kind of like one of the little baby toy boxes, where they put the different shapes in. And that really pinpoints how important precision is, because if they don't get it exact, that shape is not going to go in that box, or you're going to have so much room that it's not challenging, that just slides in because you didn't measure it correctly. So I found that to be the best lesson that I've done to start 3D printing with them, because by the time we do that and then they modify it and they get it, where it's right, then when we do our other builds in Tinkercad, they really think about that and process that. So.
And Tracy, you guys completed the challenge, the Learning Blade, and you won a 3D printer, correct?
Yes.
That's
we
great.
did. And our computer science teacher did not have one. And so we allowed her to have that one. And she is loving it. And the kids are doing some coding and printing, and you know, it's being used a lot.
Excellent. Well, thank you, Tracy. And Brandy won a 3D printer and is using that. And so, well, we definitely thank everyone for their participation. And for, if you have any questions, now would be the time before we bid everyone farewell. I will go to that last page one more time and just share this. But as you see in the chat box, there's an easy way to reach out to us. And then if you're curious if Learning Blade's for your state, you know, the way that most states you can find out if it's if there's a way to get it. So the teacher, the college professor in USC, you go to learningbladeCom/your state, and that will let you fill out a form and let you know about your state. So and then if it's not there, then just email us and we can talk to you and set you up and figure out how we can get an account in your hands. So thanks everyone so much. Thank you, Damon. Damon, do you have any last words on just the joy of 3D printing? And then I'll let you wrap us up.
Oh, it's wonderful. And I'll tell you, you're going to find that your students are going to be very creative with it. They're going to start coming up with really interesting new ways of doing things, or little needs that are very specific. They're going to realize, oh, I could 3D print a little piece or a part that would do that. You know, I do a lot of photography on the side. And so one of the things, if I ever need a knob, I can just get like a little bolt and I can 3D print a knob that fits into. And now I've got a little, you know, a handmade knob that will, you know, mount my camera to something, or the green screen that is behind our table here. In order to stretch the fabric tight, I created a whole bunch of little clips that just clip onto the side and pull it nice and tight. So little things like that, you're going to find that your students are going to start coming up with all kinds of cool ideas. And that's what's really exciting about this.
And just to a final wrap up, you got a couple more of our projects in front of you. Why don't you just show those rapidly, and then we'll say have a great afternoon. Stay safe, everyone.
Yes, so here we've got a planter that you can 3D print, so you can do a plant activity where we put soil and water it every day and get some seeds in there. This is the Mars rover programming activity that she was talking about earlier, where you print out a little Mars rover and you can rearrange these mountains so that you're trying to get to the destination square, this little X here. And so the kids would have to program it. So they'd have to turn it 90 degrees and have it go forward 2 squares, turn 90 degrees that way and go forward 3 squares. So yeah, you can introduce simple coding for a robot through 3D printing. And you can print out a whole bunch of these squares and make it really big, and a whole bunch more mountains, all that cool stuff.
Wonderful. Thank you, Damon. We recorded this session, so you'll all get a recording if you want to share it with your peers and your colleagues, and we just thank everyone for everything they've done this year for students. You teachers are heroes, you're frontline heroes, and so just thank you everyone for what you've done, what you continue to do, and know that the Learning Blade team is here to support you this year and next year and in the years ahead. If we can, reach out to us and we'd love to help you out. So thanks, Damon. Great job. Thanks, everyone, and stay safe. As I heard someone say recently, stay in positive, testing negative. Take care, everyone.